In our previous video, we have covered how to deal with numbers which are raised to a power of 0. So we have seen that anything raised to the power 0 is always 1. In today's video, we will see what happens when a base or a number is raised to a negative exponents. So let us take an example. Suppose we have 3 to the power 2. In our previous video, I have explained you that 3 to the power 2 can be written as 3 times 3 divided by 3. Correct? When we cancel out these common 3, we get 3 to the power 2 again. Similarly, when we write 3 to the power 1, we can write it as 3 to the power 2 divided by 3, which is 3 into 3 divided by 3. We cancel out these common factors to get a 3 again. So 3 to the power 0, on similar lines we said that it is nothing but 3 divided by 3 and we get a 1. Now when we make a power of 3 as negative 1, we have seen that in all the above cases 3 to the power 2 was actually 3 to the power 3 by 3, 3 to the power 1 was 3 to the power 2 by 3 and 3 to the power 0 was 3 to the power 1 by 3. So every time we are increasing the exponent by 1 and dividing it by 3. So the same we will do for 3 to the power negative 1 also. So 1 more than negative 1 gives you 3 to the power negative 1 plus 1 and we divided it by 3. So we get 3 to the power negative 1 is equal to 3 to the power 0 divided by 3. And what is 3 to the power 0? It is 1. So 1 upon 3. So 3 to the power negative 1 is nothing but 1 upon 3 can be written as 3 to the power 1. So whenever we have a negative exponents, what we have done, we have taken the base. The base here is 3. We have done the reciprocal of the base. The reciprocal of 3 is 1 by 3. And then we have made the exponent positive. It was minus 1. We made it to the positive 1. Okay. So we have seen that 3 to the power negative 1. Whenever there is a negative exponent, you reciprocate the base. The base is 3. Reciprocal of 3 is 1 by 3. Okay. And you raise it to a positive power. Okay, which can further be written as 1 upon 3 to the power 1, because 1 raised to any number gives you 1 only. Okay, let us see what if it is, say, 5 to the power of negative 3. So 1 more than negative 3, it is 5 to the power negative 3 plus 1 divided by 5, which is nothing but 5 to the power negative 2 divided by 5. Now we can again write 5 to the power negative 2 as plus 1. So 5 to the power negative 2 plus 1 divided by 5 for 5 to the power negative 2 and further divided by this 5. So this gives you 5 to the power negative 1 divided by 5 and whole upon 5, which is 5 to the power negative 1 upon 5 into 5. 5 to the power negative 1 over 5 to the power 2. Now again minus 1, so I add a plus 1 and I get 5 to the power negative 1 plus 1 whole upon 5 divided by 5 square, which can be written as 5 to the power 0 upon 5 whole upon 5 square. 5 to the power 0 is actually 1 upon 5 and into 5 square, which gives you 1 upon 5 into 5 into 5, which is nothing but 1 upon 5 cube. Okay, so what we have done here, every time whenever we are having a negative exponent, we have added 1 to it and we have divided by 5 to represent the same number. Okay, so we see that 5 to the power negative 3 is written as the reciprocal of the base 5 is 1 upon 5 and minus 3 sign changes and becomes plus 3, which we got here. Okay, so on the same lines we have x to the power negative m is equal to the reciprocal of x, which is 1 upon x raised to a positive power. And this is one of the laws of exponents to handle the negative exponents. Is this clear? So whenever any number is raised to a negative power, to make the power positive, you reciprocate the base and then raise x to a positive power. So if we have 3 to the power negative 8, it can be written as reciprocal of 3 is 1 by 3 raised to the plus 8. 6 to the power negative 2 can be 1 upon 6 raised to the power 2, or x to the power minus m is 1 upon x to the power m. I hope this much is clear to everyone. In our next video, now we will deal with the laws of exponents, how to simplify an exponent expression which is given to you. For that, we will be needing the laws of exponents, which we will be covering in the next class. Thank you.